Hi everyone, welcome back to chemistry. In this video, my goal is to get from 4.1 to 4.3. Not sure if we'll get through all of that, but we're going to try. So we'll start off with elements and symbols. So remember in the previous video, we talked about pure substances versus mixtures. And we said under the pure substances umbrella were elements and compounds. So, and we said elements are things like, oxygen, nitrogen. I'm going to add carbon on there just because I was surprised that I didn't even mention carbon, right? Carbon's really important. We're carbon-based life forms. You might have heard that expression. And that's because carbon makes up a lot of the earth and processes is required for processes on the earth and in our body. So very important element. And elements actually make up the entire universe. So they're the building blocks of the universe. And they can't be broken down into simpler substances. So you can't really break down oxygen any further than it's already broken down. It's just oxygen, right? You'll notice that on the inside front cover of your textbook, you have a periodic table of elements. You might be familiar with it, you might not, but I also gave you one on the first day of class. So the periodic table, and we'll go into it a little bit more in the future, but it's basically just a table that has all of the elements that we've discovered and some really important information about each of those elements. And it's organized in a manner that that is predictable and that you can use. So scientists, like chemists in the lab, they have access to a periodic table. So I'm always going to give you a periodic table for your exams to use as a resource, right? It's more important to me that you know how to read a periodic table, what kind of information is on it, how to make sense of that, rather than just memorizing, say, like the first 20 elements or whatever. You don't need to do that. You'll always have that as a resource with you. Okay, it won't be necessarily the one that you've marked up and made notes on and color-coded and stuff yourself, right? But you will have a periodic table to reference. Okay, so here's some elements and their names. So each element has like kind of, I call it its full name, and then it has like a nickname. So the nickname is like the symbol of the element, right? So you have things like chlorine, it has the symbol C, capital C, lowercase l. Iodine has the symbol capital I. Magnesium has the symbol capital M, lowercase g. And you'll hear me saying capital letter versus lowercase letter a lot. And that's because that actually matters a lot in chemistry. It's very important. So in lab, a lot of the time we have, we're working with chemicals, and it's important that we label those chemicals correctly. But some of the symbols are very similar looking. For instance, there's, the element cobalt, which the symbol is uppercase C and lowercase o. So that's cobalt. Versus something like C, capital C, uppercase O, which is what? Anybody know? Yes, carbon monoxide. You probably have a carbon monoxide detector in your house or apartment. I hope you do. Because it's a colorless and odorless gas. So we need those detectors to make sure that we are not breathing that in because it's toxic to us. But yeah, so they look pretty similar other than just this little O here and the big O here. So that's why capitalization is really, really important. You don't want to be picking up what you think is cobalt to use in an experiment and then finding that it's actually carbon monoxide. Likewise, when you're writing out in the future, you're going to write out these chemical symbols or names of compounds abbreviated, and you don't want to confuse people about what kind of reaction you're doing. Okay, and then over here, there's just like the source of the name. These are just kind of interesting, so you can pause and look at that if you're interested. One of my favorite ones is curium, which is named after Marie and Pierre Curie. Marie Curie was a famous female chemist, and she did a lot of work with her husband, Pierre. So really interesting. There's also one called neponium, which is, you might be familiar with this or maybe not, but Japan, the country, you can say it as Japan, or you can also call it Nippon. And that's because, and so that's what Nipponium was named after, is because Japanese scientists discovered it, discovered that element. So just kind of cool things to note there. I don't know. Okay, I talked about chemical symbols. There's a little picture of carbon. This is just more names and symbols of some common elements. You'll notice on here, some of the symbols are really similar to the names, right? And they're kind of intuitive. So we have aluminum is Al, boron is B, carbon is just C, oxygen's O, phosphorus is P. And then you got these weird ones where it's like gold is AU, iron is Fe, lead's Pb, silver is Ag, potassium's K, like those are kind of weird. Mercury's Hg. And the reason for that is that they're actually named after Latin and Greek words, ancient Latin and Greek words. So that's where some of those symbols are derived. And we haven't changed them. We've just, that's what they are. So be on the lookout for those. You'll get used to a lot of the really common ones, like on this list, and just naturally through working with them. Especially iron in lab, like the first couple times you look for it on the periodic table, you're gonna be like, gosh, where is iron? I don't think it's on here. And then you're gonna eventually be like, okay, yeah, it's Fe. And then your brain will just remember. Here's another couple examples of Latin names. Okay, go ahead and pause the video and try out this learning check. You're going to write the correct chemical symbols for each of the following elements. All right, so check your work. I'm not going to go through each one, but just pay attention to capital versus lowercase, right? Did I write iodine with a capital I? Did I write Fe with a capital E at the end? That wouldn't be good, right? All right, periodic table. So the periodic table is a really useful tool that we're going to use throughout all your chemistry classes. There's a lot of really valuable information, and it's organized in a way that's pretty helpful, at least I think. There are also other ways to organize the periodic table, and there have been lots of suggestions for how to improve it. So the periodic table is the one that we use is organized by groups. So it's organized into groups with similar properties and in order of increasing atomic mass. Okay, and we'll talk about what those two things mean. But basically, the idea is to make it as convenient as possible to know as much as possible about your element that you have without necessarily having to write that down on the periodic table. Okay, so groups and periods. So just a little bit of vocabulary here. So like I said, elements are arranged on the periodic table according to properties. So similar properties, things that they have in common. And groups contain elements with similar properties in vertical columns. So that's like moving up and down on the periodic table. And then periods, and I'll show you this on the actual table in a second. Periods are horizontal rows of elements. So they're going left and right on the periodic table. Okay, so you can put columns, let's underline columns and then rows. Okay, so going back up to, or actually I think there's a bigger one. Yeah, let's go to this one. Going to here. Going up and down, these are groups. Okay, so as you move this way, all of these columns, the vertical ones, are groups. And then the periods are the rows. So they're going left and right. Okay, so there are 7 periods, and there's a weird kind of numbering system for groups, but there's a method to our madness, and we'll talk about it. But there are 18 total groups. Okay, if you're going by one grouping system, and then there's another grouping system that has like this A-B system, and it looks kind of complicated, but I promise it'll make more sense. Okay, so groups are up and down, periods are left to right. Okay, so now we're at that weird group numbering system. So group numbers are written at the top of each vertical column. So scrolling back up here, you'll see these numbers at the top of the columns. Okay, so that's, and you'll even see these two actually. So anything I'm highlighting in yellow are the group names. Is that how they, group numbers, sorry. They refer to something else as the group names. So group numbers are group 1A or 1 is on the very left there. Then there's group 2 or group 2A. Then there's group 3 or 3B. Okay, it kind of steps down. And then you'll notice it kind of steps back up. And now we're calling them either, you know, group 13 or group 3A. So it was 1A, 2A, and now 3A, 4A, 5A, 6A, 7A, 8A. And there's a reason for that. And we'll get into that in just like a couple chapters here, I think. But I actually prefer, and I'm going to recommend that you get used to using the AB version. And I know it sounds more complicated, but it's better, I think, for our purposes. So like think of it as group 3A, 4A, 5A, 6A, 7A, 8A, rather than 13, 14, 15, 16, 17, 18. Okay. And you'll notice that the A system is the main, we call them the main group elements. So that's like these here, and then the big step up again. Okay, anything that's like the taller groups versus the B's, right, which are the shorter groups. And there's names for these, and we'll talk about them. Okay, but these taller columns are main group elements, or you'll also see it as representative elements. And those are that's the naming system I like to use. Okay. So within the periodic table, there are even more ways to categorize the different elements. And one of the ways we do that is by giving some groups group names. Okay. And we don't name all of them commonly, but some of them. You'll notice that up here, hydrogen is kind of a weird one. It's not included in this first group that we're going to talk about, so just keep that in mind. Hydrogen's kind of like a little bit of an outlier sometimes, and you'll notice that even on this periodic table, hydrogen is in yellow. Okay, hydrogen's actually a gas. It's in its natural state. It's a gas at room temperature, and these other ones are metals in blue. Okay, anyway, we'll get into that. The first group is called the alkali metals, and you do need to memorize these group names. These are very important. So the alkali metals is the first group, except for hydrogen, right? That's why it's in white. Okay. The second group is called the alkaline earth metals, and you can label your periodic table. In fact, I would highly recommend labeling it and then maybe color coding it after you have more information about like where everything is. Okay, then moving on to the right and just looking at the tall columns, I have halogens in group 7A, and I have noble gases in group 8A. You might be familiar with noble gases. You might have heard that term before. Okay, I'm also going to let you know that this representative elements, you might also see that referred to as main group elements. And then you might also see this gray group as transition metals. Here it's just listed as elements. When we talk about metals versus non-metals and stuff like that, we'll talk about, we'll probably start referring it to them as transition metals. Okay. All right, so jumping into a little bit of a zoomed in look at the different group names. Excuse me. We have alkali metals. That was our first group, right? Group 1A, except for hydrogen. So that's lithium, sodium, potassium, rubidium, and cesium. Potassium and sodium have the Latin either Latin or Greek symbols. I honestly don't know, actually. I should look it up. So they're a little weird, Na and K. You'll get used to them. Okay. And then we have our alkaline earth metals. Sorry, I was wondering something. Okay, and then we have our alkaline earth metals, which was our second group, group 2A. And these are shiny, but not as reactive as group 1A metals. So group 1A metals, I didn't actually mention it, but they are very reactive. So if you, there are actually videos online you can watch of people dropping sodium in water, and just a tiny bit of sodium in like a giant lake will have a very large explosion. So you can Google those videos. They're kind of fun. But yeah, very reactive, highly reactive metals up there. Okay, and then alkaline earth metals, they're still a little bit, they're still reactive, but they're not as reactive as the group 1A metals. And they are used in fireworks because they're really, really bright. It's interesting, copper is blue in fireworks, and we'll actually see copper in looking blue in lab. So kind of interesting. Okay, halogens, these are in group 7A, so jumping over to the other side of the main group elements. They're highly reactive and they form compounds with most elements. They really like to group up, okay? And you'll learn why they like to group up later. You might have heard of a lot of these too: chlorine, bromine, iodine. They have that INE ending. That's really typical of the halogens. Whereas if we look up here, they have a different kind of ending, right? EMs. And so do these EM. But halogens have that characteristic INE ending. Kind of interesting. Okay, and then you have your noble gases, which are like, they are very neon in color. And that's where the, neon sign comes from. But neon signs they're not always just made of neon. They have some of these other noble gases in them sometimes. So noble gases are not reactive. They're very happy and very stable, okay? They don't really want to react with anyone. They don't really want to group up with anyone. They're already doing great, and that's why we call them the noble gases. And actually the other groups want to be like the noble gases, and we'll see that in a little bit. So that's another reason they're called noble gases. They're special. They're the cool gases. Okay, so learning check. Let's identify the element described by each of the following groups and periods. So remember, when you're looking at the periodic table, you have your groups and your periods. And if you can use it kind of as a almost like our Excel spreadsheet that we worked on the other day for lab, or as like kind of like an XY plotting system where you can locate if you know the group number, you can locate which group an element is in, and then which period is it in, and you get to the element that's there. So pause the video, try that out, see how you do. Okay, let's see. So identify the element based on the following groups and periods. So group 7A, or 17 if you're using the other system, period 4. So bromine. So let's look up at our periodic table. Group 7A. Sheesh, they really made us work for it. Okay, go up here. Group 7A. And period 4, it said. So 7A, so that's this group, right? 7A. And period 4, which is this one. So I'm going to go and here I am at 7A. I'm at bromine. Okay. Bromine. And then group 2A, period 3, magnesium. Let's just double check that that's right. 2A, group 2A is, oops, I was trying to erase that. Group 2A is here. And period, what did it say? 3? Was it magnesium? Can't even remember. Yeah. Group 2A, period 3 is magnesium. Yeah. Okay, so you can use it kind of as like a coordinate system, sort of. All right, and then our last one was group 5A, period 2. So let's just do that real quick. 5A is right here, 5A. Period 2 is right here. So we are nitrogen. Nitrogen. All the way down. Gosh, what a long way to go. Okay, nitrogen. Cool. Okay, so another way that we organize the periodic table is by talking about metals, nonmetals, and metalloids, or classifying elements as metals, nonmetals, or metalloids. So you'll notice on the periodic table that there's this bold zigzag line over here. It's on the right-hand side of your periodic table. Sometimes you'll see that referred to as the staircase. And that, there's a couple cool things about that staircase. We'll get into it a little bit more later. But it separates metals and nonmetals. So metals are located on the left. And then if you keep going on the periodic table, you'll see your transition metals are here, right? But you'll see you have metals to the left. So everything to the left of that staircase are metals. And then to the right are nonmetals. And then anything that's like right on the staircase is kind of, and there are always exceptions in chemistry. You know, I'm sorry, it's kind of annoying, but there are. So like something like this is touching the staircase, but it's not actually classified as a metalloid. But anything in green is a metalloid, and those are located along that zigzag line. Okay, or along that staircase. And you'll start to memorize that. So I would try to, and nonmetals are like, you know, gases, right? And we'll get into that in a little bit. But they're ones you might be familiar with, like oxygen, you know, nitrogen, fluorine, neon. Those are things that are nonmetals. Okay, let's keep going. So characteristics of metals, nonmetals, and metalloids. So metals, except for hydrogen, are located on the left of the periodic table. They're shiny and ductile, which means like kind of malleable. And they conduct heat and electricity. Okay, so those are some things about metals. They're also usually solids, except for mercury, which if you've seen mercury ever, it's really cool looking. I think there's a sample of it somewhere on campus. We have it in one of the labs, or in the lab, the lab prep area. So I might be able to show you that. We'll see though, I'm not sure. But yeah, they're usually solids except for mercury. Mercury is actually a liquid at room temperature. Okay, then there's nonmetals, which are on the right side of the periodic table. They're dull, they're brittle, they're not good at conducting electricity, and they're very good insulators. And then they have low densities and melting points. You don't need to memorize all this. It's just some characteristics, some common characteristics. Okay, and then metalloids, which are, again, remember, those are located along that staircase on the periodic table. They have properties that are kind of in between metals and nonmetals. They're good conductors than nonmetals, or they're better conductors than nonmetals, but not as good as metals. And they're used as semiconductors and insulators because they can be modified to function as conductors or insulators. You might have heard the term semiconductor before. All right, so learning check. So identify each of the following elements as a metal, a nonmetal, or a metalloid. You're going to need your periodic table for that. Okay, so sodium is a metal, right? It's I would encourage you to actually name the group name that sodium is in. So it's a metal. Chlorine is a nonmetal, right? It's on the right side of the periodic table, to the right of that staircase. Silicon is on the staircase, so it's a metalloid. Silicon, not to be confused with silicone. Silicon is is the actual element name. Silicone is a different type of material that's man-made. Iron is metal, and carbon is non-metal. Okay. All right. Oh, this is interesting too. So, chemistry linked to health. There are elements that are very essential for our health, and there are 20 that are essential for the well-being and survival of the human body. 4 of those 20 make up 96% of our body mass. So that's oxygen, carbon, hydrogen, and nitrogen. Okay, and then most of our hydrogen and our oxygen is found as water, which is why it's so important to drink your water. And that makes up 55 to 60% of our body mass. So just something interesting. Let's just keep moving on. All right, I think I'm actually going to stop there. You can take a look at these slides if you'd like. I'll put them on Canvas. Just kind of interesting side notes, but not something that we're really going to talk a whole lot about in this class. And I'll see you in the next video.